Welcome to development hell, where all your dreams and hopes fade away. It's also called integration hell, mostly in software. It's where everything basically goes down the drain. Anyway, we're circling through the 7 circles of development hell, and well, because my project was a nightmare and I don't want you to make the same mistakes that I did, especially if you think your project is simple. So let's follow me into the abyss of development hell. Oh. Welcome back to Element 14 Presents. I'm Clem, and in this episode we're building tiny, small swarm bots. Oh, come on, it's the development hell episode, isn't it? Oh. Okay, so this is a tiny little robot that just hops around with a vibration motor. Has a little processor on it, little coin cell, does things. This is the only one that... Would you stop that, please? This is the only one out of 16 that currently kind of works. I found myself in integration hell. Let's travel through the 7 circles of integration hell and see what we're up against. It's very easy to find yourself in development hell. I thought, hey, let's do a quick in-betweener fun project, something simple. Something, well, just plain little interesting. And then, yeah, I could make instead of one thing, I could make a lot of things and have them interact with each other. That would be fun. Oh, but it's not challenging me enough. So I'm using an unfamiliar platform. I'm using an ATtiny 416, haven't worked with that chip. Didn't use the toolchain in I don't know how long. What can go wrong? Well, a lot. The first circle of development hell is overconfidence and unfamiliarity. Stay there. So I've tried to use an ATtiny 416. Haven't worked with that in ages. I never worked with that particular chip before. I've used other ATtinys. But they were always a bit fiddly in programming with UPDI, so you need a UPDI programmer to program those. You should know that before just choosing your weapon of choice. Not all ATtinys are created the same, so if you want one that uses UPDI, you better read the datasheet, because there are older generations of ATtinys that used ICSP, like the ATmegas. So be aware of these differences and read the datasheets before you commit to a platform, which I partially did. So I knew about, oh yeah, it uses UPDI, but what I forgot about was that I have, since I used it last time, switched to the Arduino IDE 2.0, and that one doesn't currently perfectly support the ATmega core, mega tiny core it is. That you need to program the ATtinys, the new ones. Well, so it's basically switching back to 1.8 point something to get that working. But that came with the problem that my computer wouldn't find the boards anymore. So I had to do a lot of tweaking and mumbling around with my computer to get that working. Yeah, and the repo is down. At least at the time of when I tried to download it. So I had to dig through my computer, find the old mega tiny core from a previous installation, manually move that over, and edit some UDEV rules on my Linux machine so I could get it communicating with the boards again. This took ages. So before you're committing to a new, unfamiliar platform, get yourself familiar with it. Maybe do a project that has no time constraints or whatever, that isn't important at all, before you're doing a project that is important with something you haven't worked with before. Yeah, maybe just use a normal Arduino. Very easy. Would have been smarter. So we have crossed the first circle of development hell. We're now good to sail away, right? Wrong. How about the other components on there? What about the supporting circuitry for that MCU? Turns out there's a non-negotiable requirement for a 100 nanofarad capacitor. Not a different one, not just a capacitor for decoupling. No, with the new ATtinys, use a 100 nanofarad ceramic capacitor on the power lines. Just do it. You will need it. Yeah, and there are some other requirements that I had to fulfill. I wanted to run this all on a 3-volt coin cell, a CR2032. So that means everything is powered via 3 volts, so all your components have to work at 3 volts. I've chosen a motor driver, and I haven't read the datasheet really carefully. I was lucky, it works on 3 volts, and you can even have a separate motor voltage on there, and it still will understand the commands. At least that's what I'm thinking. It turned out no, it sometimes reacts and sometimes don't. And at this point, I didn't really know what was up. Sometimes they would just activate like I planned. Sometimes they wouldn't. But I should go a step back and tell you what I'm actually building. So this was my original plan. You have a little PCB on top. You have a 3D printed holder for 2 little motors. These are 3-volt motors. I checked that so that they would work with 3 volts. And they just move this little board along, and it would have light sensors on here and some light emitting diodes on here, and it would roam around and emit light on the back, and the next robot would maybe follow it or do something interesting if it reacts to that bot. Well, turns out this doesn't really work. The coin cell can't provide enough power. I tried to mitigate that with a lot of capacitors and stuff, but turns out, well, the motors work on 3 volts. They don't have any torque at 3 volts. They do have at 9 volts. So what I did is I tried to use it with a 9-volt block battery, which kinda worked in a weird way. It worked a little bit, but it still hadn't have enough torque. And I even made this custom stack-up connector here, where I can put in 3 button cells in series to triple the voltage, and it still didn't work as well. So I had to do a change of plans, which was my initial plans, not having it ride on these little motors, but using vibration motors. I just couldn't find vibration motors at that time for a price I was happy with. So the first iteration already goes completely into the trash. We're still in the unfamiliar component territory. I wasn't familiar with the motors, I wasn't familiar with the motor drivers, and I still am not really familiar with the motor drivers. And switching to vibration motors came with a new problem, because those draw a surprising amount of power, and the motor drivers can only supply 0.8 volts. But at the same time, it seems that a lot of these motors that I bought like 50 at once because I wanted to build a lot of motors, a lot of robots. Turns out like half of them are broken. That's what you get from buying somewhere on the internet. Thankfully I got all my other components from Funnel, a reputable source, so I know those were coming in correctly, and I know if they are now broken, it's me that broke them. And I quickly found out how I broke them in various ways. So in retrospect, you know you're stuck in development hell and there are methods to get out there. But when you're actively in there, in the project, you have no clue about that. So of course you pick at straws and try everything and see what sticks to the wall. So I did an operation on the PCB. I disconnected a power trace to the motor driver and routed it with a Bodge wire to inject 9 volts into the motor drivers to see if it's a voltage problem. Turns out it's not just a voltage problem, it's also a capacity problem and whatever. And the motors themselves, even if I put them on a bench power supply and don't limit the current much, they're still not sufficient. So I had to switch to a different motor. I'm using vibrations motors, but these came from wherever. And so it turned out like a lot of them were faulty and I didn't test them all. And so I couldn't ever tell, is it the motor driver? Is there a cold solder joint somewhere? Or is it the motors? I had to test every single thing individually just to track down where the problem is. That took forever. I couldn't get all the bots working as I intended. They all behave differently. Like this one is stuck on once the motor engages. It's basically, I think it browns out the microcontroller or whatever, it just is stuck on. Every single one of these is different. This one doesn't do anything. Wait. I think the second LED is broken. Like, it's outrageous. So initially I just wanted to do a simple project, and I wanted to make it more interesting, like use an unfamiliar microcontroller, make the robots communicate with each other. And completely surprising, the communication bit is the only thing that I got working. As long as I don't involve any motors, that works perfectly fine. I can transmit data over multiple bots just via light sensors and LEDs. They act like a chain. I can arrange them differently and build AND and OR gates with them. It's kind of fun to move them around. Maybe I prototyped some kind of electronic game with that. I don't know. And it dawned on me, what were my actual goals with this project? It's goal uncertainty. Welcome to the third circle of development hell, when you don't even know what you're actually building anymore. So for you, it might be, hey, I want to have a robot that moves around. It could also be, hey, I want two independent devices communicate in weird ways. That's a completely different goal. And for me, it's usually, hey, I want to make an interesting video for you. So is my goal even to get these robots working? No, I have to make them do something interesting and show you something interesting about it. For example, that the capacitor values on these electrolytics on the motor drivers, they matter a lot. They can make the difference between the motor even engages, or it just hums, or it's stuck on because it drains all the power away from the microcontroller. And it turns out that's not easy to find the right value. You have to experiment a lot. And I also found out that don't buy capacitors in bulk. I use mainly new old stock ones that I got many years ago, and they dry up and they don't perform equally. So I have some, like they are integrated in here cleverly. I have a lot of ones that have, these have the same microcontrollers on there, the same capacitors on there, and they perform completely differently. This one is stuck on again, and this one doesn't engage the motors. Nice. So how do you overcome the third circle of development hell? You think about what you're actually trying to achieve, and maybe you should just take a new project or give the whole project a new angle. Maybe they do something you never intended, and that's the actual way forward. Hopefully. I told you I made 16 robots. Only one is kind of working like I wanted to. Turns out I wanted to make 25. Thanks to Isla for providing all these PCBs. You are like an invaluable resource, and these were all made perfectly. It's my execution skills that made them non-functional. So these PCBs still would work great if I would change the project to something that would work with those. So welcome to the fourth circle of development hell. It takes a lot longer to assemble multiples of one than you would think. So when I'm making a project video, I usually assemble two of these. One that you see in the video, the other one for debugging, or maybe I use two and one gets broken, so I still have a spare one. But this time I wanted to assemble 25, but it's really added up, like how long it took to assemble all the SMD components, to print all the 3D printed parts and stuff. It just adds up. And there is just a time constraint that you have in your day. So never underestimate how long it takes for you to build multiples of one and even make sure that the quality is consistent. Which brings us to the fifth circle of development hell. The hardest aspect of bringing something to market is not even like inventing it or like developing it as good enough that it can be certified and sold. It's about making it possible so it can even be mass manufactured. Things you build at home, you can spend a long time in carefully soldering it up, carefully debugging it, and then you have one working unit. If you think, hey, I debugged the project once, I just built 15 other units the same way than the debugged one. No, that's not how it works. You are basically testing and debugging each unit again. The solution that worked with one might not work with the other. I had the problem with aging electrolytics. bad solder joints. My reflow oven doesn't heat evenly in all areas, so some of the boards were perfectly reflown, the others weren't, and I had to rework them, and during rework there can be errors. Sometimes you put on a component backwards. There were some LEDs that I put on backwards because I can't, like, my eyesight is not that good and I can't really tell the orientation at a glance. I have to like take a photo and zoom in to actually check. And if you're doing 15 at a time, do you really take the time to do that? So I didn't, and it bit me. So manufacturing consistency is really hard to achieve in the home shop, especially if you do not have the time to check everything after each step. So no matter if you're building like stuff at home or if you're preparing for an engineering job or what, never underestimate the variances that can happen. And for something you can even like design in ways to adjust things like trim potentiometers or spaces where you can put pull-up or pull-down resistors in case you need them, or test points and whatever. These are all really important. The sixth circle of developer hell might seem not so serious because it's stuff that you can overcome, stuff that you encounter all the time. It's just general hiccups, like programming hiccups, like something wasn't soldered correctly, like you connected the flashing thing wrong. Stuff that happens when you're not careful enough or when you just run out of time and you get sloppy. I tried to save some time and I thought, hey, that might be a good aspect to the video. Let's let an LLM program these bots. It's just a simple thing, they should just follow light. How hard could it be? Turns out, if you trust an LLM on programming microcontrollers, you shouldn't be trusted. That's not just bashing on AI, that's just never trust the code that goes out there. You can use it to help you do repetitive stuff within your code. Like, hey, I need a for loop that iterates over this and does the same thing over and over again, and it just types it for you and they copy paste it in. But don't let it do the programming structure. It's basically sloppy copy paste from wherever and connecting it with made up libraries. It can be a real trap or fall into where you try to debug something that was never meant to work. And it's the same thing like plugging in the wrong programming adapter and you're chasing a phantom for ages, basically. And if you're already, and your mind is already cramped and you really want to just finish this project to get it out of your system, you basically can't. Sorry. The final circle of development hell is the compounding of all these issues. So put that lamp away, let's be serious. You have a compounding of issues. Every issue that you encountered on this travel in this video means this affects all the other ones. If you're missing one aspect in another circle, then it will bite you later on. It's really hard to identify these when you're actually there. If you get someone from the outside to look at your project, that helps a lot because they can see obvious errors. They may see, hey, yeah, your microcontroller can't be programmed. You know what? Because you didn't connect power to it. It could be that simple. For me, it was, why doesn't it flash? Well, you should have turned it on. Oh, and I should put in a battery to begin with. Like, I didn't even check that now that I'm just filming a video. Get an outside view to break out of development hell. And if you have to abandon the project or give it a new target, see what it actually can do and what can be done with it so you don't lose the invested cost in components and in your time, and reevaluate. Well, I'm currently deep into development hell, and my way out of this is basically I flipped the video script and made a video about development hell, because frankly, that might be more interesting than these little bots. There's a status in this project where all the robots work perfectly, and it's whenever there is no, like, look at the sensors, they work perfectly. These are by Wirt. These are really good, easy to solder sensor, and they're not very sensitive to like moisture and stuff. I love them. But the point is, this works perfectly fine as long as you don't involve the motors. So what could it be? Is it a brownout issue? Is it power draw? Is it motor noise that injected into the microcontroller. I don't know. Maybe you want to give it a try. All the files for this project are for free for download on the Element 14 community. Please let me know, check them out, give your thoughts, or try them out. Maybe you can make a functioning little robot out of them. So a mediocre robot project turned into hopefully a quite helpful episode about development hell, in case you're stuck there. I've been there. So connect with me on the Element 14 community. I gotta go, because honestly, I think I'm gonna need a day off or two. And then another project is waiting for me.